Artificial intelligence can mislead, but it also holds promise as a sentinel network for underwater ecosystems. On a small research catamaran anchored off Lizard Island, engineers hand-launched drones programmed to fly overlapping grids. Their cameras capture hyperspectral data, slicing light into hundreds of color bands invisible to the human eye. A deep learning model back on shore processes the mosaics overnight, grading each coral pixel by bleaching severity, disease risk, and even probability of recovery. This February, the University of South Australia unveiled a cloud-based dashboard called Reef AI Monitor that fuses drone outputs with satellite sea surface temperature forecasts. The system crunches 50 gigabytes of data per day and generates predictive heat stress maps up to 4 weeks in advance. Conservationists can now schedule shade tarps or selective coral shading operations before lethal thresholds are breached. Early trials saved an estimated 18% more coral cover on pilot reefs compared to previous methods. Beyond monitoring, AI assists in selective breeding. In land-based nurseries, computer vision systems track growth rates of heat-tolerant coral genotypes, flagging anomalies and recommending which fragments to outplant. The process accelerates what once took months of manual measurement into real-time analytics. Some critics argue that relying on techno-fixes risks normalizing high emissions. Yet proponents view AI as triage staunching blood loss, while humanity pursues deeper systemic surgery on climate change. The technology even augments citizen science. Smartphone apps like ReefSnap now let snorkelers upload geotagged photos that machine learning algorithms classify within minutes. The resulting crowdsourced dataset has ballooned to 5 million images, giving researchers granular insight into bleaching progression along coastlines previously too remote or costly to survey. Still, experts emphasize that smart cameras cannot reverse warming seas on their own. They are diagnostic tools, not cures. The ultimate feedback loop must run from reef data to public policy, translating colorful dashboards into decarbonization laws robust enough to cool oceans. Technology amplifies human choice, and its next update depends on legislatures, not firmware. Images of scientists planting nursery-grown coral fragments onto steel frames make for inspiring social media reels, but the hard numbers paint a sobering picture. A meta-analysis published on the 8th of April in Nature, Ecology and Evolution reviewed 850 restoration projects worldwide and found that 38% failed to establish viable colonies 3 years after transplantation. Scale is the Achilles heel. All active projects combined cover less than 0.1% of global reef area. Without emissions cuts, repainting reefs is like failure modes vary. Some transplants bleach within weeks because nursery conditions cannot prepare corals for sudden temperature spikes in the wild. Others succumb to algal overgrowth fueled by nutrient runoff. Many simply detach during storms that are now stronger and more frequent. Each setback drains budgets that NGOs could spend on upstream solutions like water quality improvements or renewable energy advocacy. Yet restoration science is evolving fast. New techniques pulse low-voltage electric currents through metal frames, encouraging calcium carbonate accretion and faster coral skeleton growth. Experimental microfragmentation breaks donor colonies into postage stamp-sized pieces that fuse together, accelerating cover. Geneticists are crossbreeding heat-tolerant strains from the Persian Gulf with Great Barrier Reef species, hoping to transfer thermal resilience. These approaches offer glimmers of hope, but one lesson stands out. Restoration must be coupled with aggressive mitigation. Planting corals into a warming sea without curbing emissions resembles mopping a floor while the tap still runs. Policies that slash greenhouse gases act as the plumber, restoration as the mop. Only together can they keep the house from flooding. Crucially, community leadership matters. On the Torres Strait island of Masig, traditional owners integrate coral gardening with sea ranching of giant clams, creating a diversified reef economy that funds both conservation salaries and cultural education. Projects that embed restoration inside local livelihoods report 25% higher survival rates because caretakers patrol daily, removing pests and logging temperature spikes. It's a reminder that reefs are not just ecological treasures, but social infrastructures intertwined with identity and prosperity. Coral reefs occupy less than 1% of the ocean floor, yet underpin a quarter of all marine species. Remove the scaffolding and food webs unravel. Scientists studying reefs off Kiribati observe fish biomass plummet by half within 6 months of severe bleaching. Predatory fish, which depend on abundant prey, crashed even harder, triggering a trophic cascade that left waters eerily quiet. Such biological silence has socio-economic echoes. Reef fisheries feed hundreds of millions and generate $36 billion annually. Beyond fisheries, reefs act as living breakwaters, absorbing up to 97% of incoming wave energy. A 2020 modeling study estimated that losing reef height by even half a meter would expose 300 million people to increased flood risk. Insurance analysts now factor bleaching forecasts into cyclone damage pricing, nudging premiums up for coastal resorts from Belize to Vanuatu. Investors tracking environmental, social and governance metrics notice private equity giants withdrew $2 billion from... Cultural heritage hangs in the balance too. In Palau, myths speak of reef spirits called chessels that guide fisherfolk. When bleaching struck the archipelago in 2024, elders held ceremonies imploring the chessels to return. Anthropologists recorded grief akin to bereavement, framing coral death as a loss of ancestral memory carved into stone-soft skeletons. Economists attempt to quantify that intangible grief. A 2024 assessment valued the existence benefit of the Great Barrier Reef, the amount people are willing to pay just knowing the reef persists, at $56 billion Australian dollars. That figure dwarfs annual ticket sales for every theme park on Earth. The reef is not just a place but an idea, a living symbol of vibrancy and interconnection. Its fading colors signal a broader moral erosion, daring humanity to choose between extractive convenience and the cascading consequences therefore extend from plankton to parliament, from microeconomics to meaning itself. Failing reefs are a mirror. They reflect our collective willingness to trade long-term stability for short-term profit. Cracks in that mirror promise to distort countless other systems we take for granted. The storyline of the Great Barrier Reef is still being drafted. Corals possess latent superpowers. Many can spawn larvae that drift hundreds of kilometers, reseeding scarred zones. Some harbor heat-tolerant algae strains, waiting for a chance to dominate. If emissions peak in the next 5 years and decline sharply, climate models suggest the frequency of lethal heat waves could fall below recovery thresholds by mid-century. That buys time for active interventions. Shade structures, cloud brightening, localized cooling, and more. Researchers are even experimenting with acoustic enrichment, broadcasting healthy reef sounds through underwater speakers to lure fish back to damaged sites. Early trials doubled juvenile fish recruitment, hinting that rebuilding a living orchestra might accelerate the return of coral symbionts. Meanwhile, policy innovators propose blue carbon credits that reward nations for protecting reefs which lock away carbon in fish biomass and limestone skeletons. Ultimately, the fate of reefs rests on a universal metric: degrees of warming avoided. Every fraction matters. Drop future peak warming from 2.7 degrees Celsius to 1.8 degrees Celsius, and you increase the odds of reef persistence by more than 50%. That statistic collapses a labyrinth of climate complexity into a single, actionable truth. What humanity chooses to emit or not emit this decade will echo through reef canyons for thousands of years. Imagine, decades from now, snorkeling with grandchildren across fields of technicolor coral that survived thanks to decisions you helped shape today. Their laughter would mingle with the clicks of parrotfish and the distant croak of a giant clam snapping shut, a living soundtrack testifying that hope, like coral, can be fragile yet astonishingly persistent when given room to grow. Conversely, picture a world where those same grandchildren study bleached reef skeletons in museum tanks, reading plaques that describe vibrant cities of life lost to irreversible warming. The choice between those two futures is an open script, and the ink is the carbon written into atmosphere every day. The pen, however, is still in our hands, and it is not yet dry. Coral polyps cannot vote, but they do cast a silent ballot in every climate summit, their very survival tallying the outcome of human choices. Listening to that quiet referendum and acting accordingly would be the most extraordinary collaboration in Earth's history.